Today, I'd like to introduce you to our way to survive through CERN's organic webscape with Kubernetes and the community of makers. So, sorry for everyone who was at yesterday's presentation as well, but I think that it merits to say a bit what CERN is, because we are the world's largest particle physics laboratory. We host these huge machines, actually the world's largest machine, the Large Hadron Collider, which is a network of superconducting magnets sitting on a tunnel for 27 kilometers underneath the Earth that accelerates particles to very close to light speed and tries to understand fundamental questions about the universe. So particles are accelerated in our big machines only to be smashed together at the center of these building-sized, huge three-dimensional cameras that are particle detectors. And from these collisions, the cameras that are surrounding them understand the tracks of particles, and they try to reconstruct from those tracks their history and their identity, essentially solving a huge puzzle of connect the dots. Well, this will help us understand how the fundamental forces of the universe work. So this is very much a question of collaboration, of being able to pull together resources so that we can bring enough computational power and knowledge to bear to solve these huge problems. And that is why at CERN there has been a computational grid since a very long time ago, and also why the web itself, the World Wide Web, was born at CERN, out of a need for collaboration. So here we are today on a very similar topic of collaboration and of public outreach, to talk about the infrastructure that hosts CERN's public-facing websites, including its homepage, home.cern. On top of the homepage, which on its own serves about 30,000 unique visitors every day, the infrastructure that we will talk about today hosts about 1,000 other websites, including their test environments, and a bit more actually. And it can peak at even 120,000 unique daily visitors, and that is for a view of just 1 month. So we're talking of an infrastructure with this level of scale, including all these websites and this number of visitors. And you might notice that home.cern on its own, 1 out of the 1,000 websites, is taking something like 30% of all the traffic. So we have a few very heavyweight sites and a lot of very lightweight sites in terms of traffic, if you like. But let's take a step back and see what exactly our journey is going to take us through. First of all, I'd like to talk about the credits, the people that are involved in this effort. That includes a team of web builders, a team of infrastructure builders, and a community of site builders, all with their own purpose. All these 3 actors came together first in the first implementation of the Drupal service, which served the needs of the community for a very long time and was very stable. Until at some point, a moment of crisis came, where the team started dwindling in numbers, tech debt was accumulating, and Drupal 8 came along to shake the waters. For this moment of crisis, we needed an equivalently strong solution. So we went forth with a technical and a human solution to this problem, which I would like to share with you and see how it has performed, how it has served us so far, and then take a glimpse beyond the horizon and see what lies ahead. So if you're with me, let's get started. First of all, our actors, because it's always about the humans first. Once upon a time at CERN, there was a web team, an infrastructure team, and a community of site builders. Now, the site builders, they could already build websites with other means. They could build websites with means that required coding knowledge, that essentially required from them to be web developers. But what they really wanted was a low-code platform that was composable, with reusable pieces, and that provided a consistent look and feel that could reinforce CERN's brand to the public. So that is what the 2 engineering teams came together to provide for them. The web team created the CERN theme, which provided this standard look and feel, and also integrated with the other CERN services, while the infrastructure team created the homegrown Linux infrastructure to provision and maintain and operate over 1,000 Drupal websites, even though at the beginning we only thought they would be 100. But let's dissect a bit the site builders and what their profiles are, because they are very, very varied. Actually, it turns out that very few only of our site builders have any professional background in site building, in web development, or especially in Drupal itself. No, actually, most of them are physicists or administrative people, the people that form the backbone of CERN's community. And they take on site building as this additional role that is not their primary purpose, that is not their primary function, but it is that job that someone has to do. And so they end up doing it. They need all the support that they can get to learn fast and to be able to deliver on their efforts. Meanwhile, the visitors to our sites, yes, they are the CERN community, but most importantly, they are the general public and the stakeholders of CERN, the member states and the authorities. So all of these two types of users must be satisfied by the use of the CERN Drupal distribution and the infrastructure that provides it. We have to cater to all of their needs. And when I talk about the webscape, that's because it's not just home.cern, which also has additional names. It's a whole set of websites. All these names that you see here are just a drop in the water, in the ocean. There's a lot of websites, and why do we even have so many? Why there are so many choices? Because site builders are confronted with exactly this big set of choices when they start their project of building a site at CERN. They can use a technical tool that if they know how to write bare HTML and PHP, they can serve it behind an Apache server. Apache provided by the infrastructure, and they have to write the rest. Or they can use a SharePoint site. Yes, that is low code, one might say, but it turns out to not be composable enough for their needs. Or they might create a platform as a service website, which would be a web app, and again needs a lot of code. So compared with all these choices, there is a difficulty in choosing and in finding something that satisfies this low code principle. The reason why we have so many choices and so little standardization, well, it is very closely related to CERN's values of academic freedom, because we are very much an academic institution, and also because there really have to be a lot of independent websites, since the CERN community rather, actually encompasses a lot of autonomous entities. It is not just CERN itself, it's the experiments, it's the departments. So these factors, combined with the fact of the history that the web was built here and the long time that this experiment has been running, ends up with a phenomenon that there are about as many websites as there are people in the community. And most of those tools are for coders. So the average site builder that would come to our service is going to come to us with a feeling that I just want a website. Can I get one? Please. This is what we have to provide. This is the need that we have to serve. I think that this slide very funnily summarizes essentially the main feeling that we have to serve with this infrastructure. Okay, well, now that we know more or less the need that we are serving, let's see how the first implementation of the Drupal service actually provided for that need, in order to have a comparison and to see what changed with the crisis came. So this is a Drupal site, but from a different perspective. You all know that the Drupal site has a database and a file system directory, and also it has a lot of modules. Certain Drupal sites have some standard modules, let's say 3 out of the 4, but site builders are allowed to put their own modules in. They are allowed to download the module from the web and upload it to the website and store it in the local directory of this specific website. So this customizability means that our infrastructure needs to be able to take care of websites that are not unitary, that can be running different code from each other. And also, it needs to be able to automatically provision them, to maintain them, to back them up, to clone them, all these operations, and when the time comes, to upgrade them. And do that not just for one, but for 1,000 websites. So that's more or less the long of what the infrastructure needs to provide. Well, if we took an HTTP request and follow it along its path, we can see how the infrastructure actually looked like in the past. So this old infrastructure was composed of physical machines. As the HTTP request came to the physical machine, it would be confronted by an Apache host, which would direct it to a backend PHP FPM pool process that was serving a single site out of a multi-site deployment of Drupal. This set of servers, they all communicated with a shared file system, while the Drupal site itself was this, let's say, simple depiction that I showed also in the previous picture. So far, so good. This infrastructure was stable. This infrastructure served us for a long time, but it had actually a lot of shortcomings, you might say. First of all, because of this design of a PHP FPM process pool, it meant that there was little isolation between the websites. They were all sharing the same process. This means that there was, for example, an incident once of an incorrect configuration of one of the PHP ini files of one of the websites, and this caused the entire infrastructure to have a downtime for a bit. In another case, the Drupal code, because of the multi-site deployment, is shared between all websites, which means that there is very little flexibility for customization. The websites can't be too different from each other. They can't be running different versions of Drupal. They have to be, at the same time, closely aligned to run exactly the same code, which also causes problems for operations and for upgrades. At the end of the day, the infrastructure was mutable. There was no version control. It was non-standard. It wasn't very scalable, not really too robust. So all in all, I could say that it lacks all of the benefits that a cloud-native infrastructure would have out of the box. And this is more or less our main point that will come in handy a bit later. But despite all of these shortcomings, for many years, it was running stably and smoothly. Until one day, a moment of crisis came with Drupal 8. Now, I want you to depict that Drupal 8 came at us like a train, and we were these people lying here on the tracks. The reasons were quite a few. First of all, because our infrastructure was so custom, when contractors undertook to migrate some of the most critical and major websites to Drupal 8, they were confronted with an environment that they did not know how to work with, and that we had to very customly assist. On the other hand, because of this characteristic of the flexibility that we offer to our users, where each site admin can add their own modules to their website in addition to the ones that we provide, this also created a responsibility gap, an expectations mismatch between the infrastructure administrators and the individual site administrator as to who is responsible for those additional modules. And to exacerbate the issue, the teams of the engineers, both of the web team side and on the infrastructure team side, were dwindling in numbers. So this created a perfect recipe for a crisis. We had to do something about it. Let's see what we did. First of all, let's imagine for a second. Let's imagine how our ideal infrastructure would look like. Already we know that we want these features here on the right: reliable hosting, custom modules, automatic updates, failure recovery. To some extent, the old infrastructure was still providing these, but maybe we could improve. Ideally, in order to minimize our degree of accretion, our rate of accretion of technical debt, we would also want a high degree of reusability between infrastructure components. And to make it even more interesting, we can add to our requirements a few new things that did not exist before, and that, as we saw, would be very useful, such as isolation between the websites, more flexibility to the individual users, and also to be able to tune resources, because as you saw on my traffic diagram, comm.CERN is on its own about 1/3 of the traffic of the entire infrastructure, or 1/4. At the end of the day, when a house looks like this, you can't really add another window. So that meant that we couldn't do incremental improvements. we had to start from the beginning with a big modernization campaign. So that's what we embarked on. We embarked on a journey to renovate our house. We knew what we wanted to do, what our requirements were. We also had access to our extended colleagues from CERN's Web Frameworks team, who were embarking on very similar projects at the same time, and were creating a set of shared platform as a service components that provided, for example, integration with some of CERN's other services. We could use those things and build our own extra components, specifically for the Drupal service on top, which were essentially just the tip of the iceberg. And we could do all that with a crew of an old junior team that had access to experts to consult from our more senior colleagues. So with these ingredients, we managed to create a cloud-native Drupal infrastructure. So let's take a look back to the previous infrastructure and compare. This is the same diagram that I showed to you before, the HTTP journey through the physical infrastructure. Let's see how this looked like when we went to the cloud-native infrastructure. Essentially, the physical machines become pods, become nodes in a cluster which host pods. Instead of here where all the servers lie on the same, let's say, availability zone in the data center, now we could even provide redundancy by going through separate availability zones. The Apache and Drupal multi-site becomes a single deployment of Nginx and PHP for every Drupal site, which normally is served by a single pod unless it is a critical website which has the redundancy of being served by multiple pods. The deployment of Drupal itself looks very similar, apart from a critical difference. This time we have composer projects, and that opens up a lot of capabilities in the Drupal ecosystem. But I will not go into too much detail on how this infrastructure works, because we had a talk about that yesterday, and I highly encourage you to go back and see how it works if you're interested in the technical details. We were also going into more details about the Kubernetes part and the main concept that we use from the Kubernetes world, the concept of the operator, on a talk at KubeCon 9 months ago now. So I just linked to you these two resources. Here, I would like to actually focus now on the second part of the solution that we gave, the human solution. And that essentially boils down to growing up a community from something that was considered as a chore. The problem was that infrastructure support teams, formal support channels, can only do so much. Too many requests coming in, too few engineers, and they were very frequently overloaded. We are in a situation where knowledge attrition takes away knowledge from us at all the times. Engineers come and go. There is a rather high churn of people. And with this process, coupled with the teams growing smaller, inevitably knowledge gets lost. Expert knowledge gets lost. And this is the problem. On the other hand, we realized that the Stack Overflow model works. We all use Stack Overflow, right? It's a community where there are a few dedicated experts, many people that might know a little bit. So you ask and you expect that anyone, not simply the expert, is going to be able to answer to your question, maybe not very right from the beginning, but it is information that will help you. And that information stays there. It is documented and everyone can access it after. So that is how this model battles knowledge attrition. And at the end of the day, it is very much aligned with CERN's DNA, its core values, because CERN values cooperation. CERN is built on cooperation. It is an intergovernmental organization that is essentially the essence of cooperation between states that might actually not even be on the friendliest terms with each other. So building on this, let's say, social capital, we provided a solution relying on a discourse forum. This is the heart of the Drupal community at CERN. A discourse forum that has a lot of activity, a lot of topics that are where people ask questions and are usually being answered by other members of the community, with answers on more difficult questions, let's say seeded by our experts and then accessible. And the modus operandi here is that when a site builder or an editor on a website wants to do something and encounters trouble, they can, before asking on the formal support channels, they can go to Discourse and try to find an answer to the problem that has already been asked before. And if we look at the kinds of questions that people are asking on Discourse, they take all sorts of shapes. There's questions about modules. There's questions about site building or on the front-end side of things. There's question about some modules not working or how to add permissions. There's all sorts of questions covered. Everyone asks everything. And actually, Drupal community is not the only Discourse forum at CERN. Now we have something like 50 instances of Discourse, which cover more than 40,000 users, which is an impressive number if we consider that the CERN community itself, the people that are closely affiliated with CERN, is about 10,000. So this means that a lot of people from collaborations are working on the Discourse forums. Well, these were the two solutions, but let's actually see if they have helped us in practice. Have we been able to do something with them? First of all, I would like to share with you a snapshot of the development timeline of our Drupal infrastructure. Essentially, development took, you could say, 1 year, since right now we are in the process where we are doing production migrations. The development started last October, and we first tried to deploy things manually on Kubernetes, and then gradually automated the process and went through the integration with the external CERN services until we reached the point where we could template and then eventually perform the migrations. We followed an incremental approach, and we had a lot of moments where we had to go back and revisit some previous decisions in our development. And one of the most difficult things was actually integrating with additional CERN services. Now, this is a scary diagram that shows how the infrastructure works, but we can forget this part and look just at the left part here. What I want to show is that there are a lot of services at CERN that we integrate with. There is authentication, there is databases, there is storage. And essentially, when it comes to the databases, for example, in the same project, we had to upgrade the database version from MySQL 5.7 to MySQL 8. And this migration process ended up causing us some issues that we had to resolve, and we could collaborate with our colleagues from the other services to make these changes. And also on the authentication side, we used to be using a previous authentication service with direct, let's say, closer access to LDAP, also performing some LDAP queries, that was relying on SAML. And we changed that now by removing the SAML module, the simple SAML PHP module from Drupal sites, and instead using the OpenID Connect module to move to OIDC configuration, to OIDC authentication with a new CERN authentication service. So what I want to show is that this project was not just about the Drupal infrastructure side of things, but also about changing our plugins with the external ecosystem. And now we are at the phase where the production migrations are underway. We have half of our sites already previewed on the new infrastructure, and everything is coming up in just a bit. And we know that our users are actually already excited with the new features, especially with the prospect that now with custom composer projects, they can add their own modules in the composer project of their website, which before was impossible, and it meant that they could not add a lot of modules that had some global dependencies. And at the same time, since Drupal 9 is just around the corner, we provide them with previews of how their site will look like in Drupal 9, so that if there is any problem with especially their local modules, it can be fixed soon. When it comes to the Drupal community, we can see that it is actually engaging our users. When the pandemic started, these are the monthly posts here, we noticed a sharp spike on the number of on the usage essentially of the community. I have no idea and I can't explain it, but maybe it comes down to people not finding the answers that they were getting face-to-face before and looking to the forum now for it. And on the other hand, we see that there is a sufficient level of engagement with the community, hovering a bit below this 20% line here and sometimes overtaking it, which is considered a good benchmark for, let's say, successfully engaging platform. So this is what I wanted to share about our performance with this renovation project, and maybe now we can take a glimpse beyond the horizon and see what else is there. We have some technical goals. We would like to explore new use cases of Drupal. We know, after all, that Drupal is now very friendly to be used as a backend, and we want to encourage this use case and see if our community is eager to uptake it or not. So to do that, we want to make sure that our infrastructure makes it easy to use Drupal in this manner. Another thing is that we want to reevaluate our users' needs, listen to our users, and see if they also want other low-code solutions. We feel confident that our infrastructure is adaptable enough that it would be easy with little extra effort to also offer other solutions. And finally, if there is interest, we would like to give back to the community the infrastructure that we are building and make sure that our operator works outside of CERN just as well as inside CERN. Because all of our projects are open source and Apache licensed. So I'd like to close with a question to you, actually, that is related to what I just asked. Is this infrastructure, as I described it, useful to you? Would you be interested in this being more easy to use outside of CERN? My colleagues have just created a poll where you can actually answer this question. So that's all that I wanted to share with you. Thank you very much for being here with me today. And now my colleagues and I, we're coming online to have a discussion about anything that that you might be interested in. Thank you. Okay, then. So I don't know, I haven't been following the chat so far.
Hi.
Hi, Kat.
Hi. I'm from CERN as well. I've been supporting Konstantinos in the user side of the non-dev side of Drupal.
Kat is one of our expert site administrators, and she's here to be able to answer questions from the other side of things, the side of the user of our infrastructure.
Yeah, so that the image with the person with the gun, just want a website, that's me.
Exactly. Do we have any questions already in the chat or the Q&A?
A little in the Q&A. Yes, there's some questions in the Q&A if you want to. Yes, technical questions. Over to you.
Okay, maybe Francisco or Ayula are also going to join for technical questions. Okay, first of all, let's see the question that I see here on the chat. Is there any cost involved? Well, of course there is cost involved. There is cost involved primarily in human resources. If I understand correctly, you mean if there was cost involved in designing all of it. This is not running on public cloud. This is running on CERN's internal cloud. We have an OpenStack cloud inside CERN. So this is not, how can I call it? This doesn't come with an explicit price tag. So I can't tell you that this infrastructure is costing us that much in terms of computing resources. But it has certainly taken a lot of effort in human resources in order to create it, with a development timeline that I showed of 1 year. Our team is essentially composed of 4 people. We can imagine 4 people working full-time for a year to build what I have shown here. And it is not just those 4 people. We have a lot of expertise with our close colleagues that have assisted us a lot and have spent real time on it while it wasn't their primary duty. No, individual sites are not charged the cost because we do not have this kind of policy. So all people at CERN, all CERN users are able to create sites and use the service ad hoc with, let's say, a fair treatment system to reduce the possibilities of abuse. we rely on quotas, where projects apply for a sufficient quota that satisfies their needs. There is a justification process if someone wants to do something big.
Konstantinos, if you go into the Q&A, there's some questions in there.
Let me go to the Q&A. Did you try to move ephemeral Drupal files, compiled JavaScript, etc., from main storage to separate? I will interpret this as a question about the migration, because during the migration, as we showed also on yesterday's presentation, the process involves copying all files from the old servers to the new infrastructure. So then we copied everything that is on the Drupal sites file system and everything that is on the Drupal sites database. And then running a lot of drush command line instructions like drush cache clear to make sure that anything that is stale can be refreshed. So I'd say yes. In case I haven't understood the question, please say so on the chat so that I can answer better. How do you handle non-production environments? Do you deploy a full environment per branch? This is a bit of a follow-up from yesterday's discussion as well, from Olivier. So here I haven't gone through the GitOps deployment model that we have. What I will say is that the CERN Drupal distribution is not just a repository with a composer project inside, but it is also a GitOps workflow and a CI/CD workflow behind it that brings it to life. And the way that we work with that is that each Git branch that is that starts with a V, let's say, it is perceived as a version branch, which users can choose between. And users can say that they want a site with Drupal version 8.9 or a Drupal version 9.2. So this is independent from different environments, non-production environments, because the way that we handle that is that people can simply create an independent Drupal website with the same authorization permissions as the first Drupal website that they have. We use Kubernetes namespaces to separate authorization domains. So in the same namespace, in the same project, people can create more than one Drupal sites. There is a concept of a Drupal site. But this is getting into a bit of a more technical question, and we can follow it up later if you want. The third question is, how do you run custom one-time jobs in Kubernetes? For example, to make a dump of a specific database, export some data, apply updates, etc. There are actually two answers to this question, and I'm grateful that you're asking it, because this is one of the two answers. It's exactly where we spent a lot of time to develop it, the update specifically. So the first and easier answer is that in Kubernetes there are cron jobs. So when it comes to repetitive tasks, such as running the Drupal cron job, we have a Kubernetes cron job that launches that periodically. I don't remember what the period is, and executes that task. But for the other tasks that are not necessarily a matter of time, but are also ad hoc, such as cloning websites or making dump of databases, which is something that happens naturally when we take backups. These processes are automated by our infrastructure automation system, what I called an operator. So the operator is a component that lives inside Kubernetes, and it creates downstream resources. It is actually the one that creates the cron job. And it also has specific workflows in order to update the Drupal site. Essentially updating, I would encourage you to look at our KubeCon presentation that I linked in the slides to see how it works in more detail, because we have described it there. Another question was, what do you think about joining Nginx and PHP for Drupal instances into one container? Okay, thank you very much for this question, because this is super prescient right now. Initially, we thought negatively of what you're suggesting here. We thought that it was a better idea to have different images and to reuse upstream components as much as possible. So right now, our infrastructure looks like a single Drupal server pod has a container that runs a PHP FPM server with one site builder image behind it, and another container that runs an Nginx server with upstream Nginx image, really, nothing too custom there. But in order to make this work, we had to provide a way for Nginx to see the Drupal files from that only existed in the site builder image. So one way to do that was to put everything in a persistent volume. We didn't want to do that because Drupal codebase, according to us, needs to be versioned. The second way to do that was in a bit of a hacky way to enable shared process communication among the containers and to tunnel through the process files to see from one container the file system of the other. This caused us some issues. The third way was with an init container that copied files from the one container to the other in an empty dir. And apparently right now, this is also causing us issues. So at the moment that your question comes, we are actually thinking of creating a single container with both Nginx and PHP, and to serve a single image, with both of them, and to serve two separate containers, one for Nginx and one for PHP as we have now, but from the same image that has both components in it. Before I continue with the technical questions, is there any other non-technical question? Maybe Kat can say.
No, it's all technical, except there's a comedy night question.
Oh.
Out of scope here.
Kat, I don't know if maybe you have an opinion about the governance questions, and if you have anything to add to that, to what I said before. Sorry, I missed that. I was reading the comments. Sorry, was that for me? Sorry. Because I answered the governance questions and about whether sites are charged a cost, and I wonder if you have anything else to add to that. Otherwise, I can continue with the technical questions.
Not much to add. I mean, yeah, everything at CERN's provided to CERN staff and associates for free, effectively. It's a service for us, so we just use it and hope. It works very well. It's just in terms of governance, it's as Konstantinos said, it's total academic freedom. So everybody at CERN has the right to create as many, well, within limits of infrastructure, as many websites as we like. I personally own about 35 websites, which I think might be more than average, but this is quite a normal situation. So anyway, that's my take on that.
Kate on the Q&A is asking, you mentioned new cases with Drupal as a backend deploying other low-code website solutions. Which low-code website solutions do you have in mind? So which solutions we would have in mind to deploy comes out from what we hear from the Drupal community at CERN. And one name that comes up a lot is that some people would like also a possibility for WordPress at a high level of service. So we're thinking of providing WordPress as well. The WordPress will be deployed with a model very similar to Drupal. So if we go down to that direction, which we haven't yet decided, we think that it would be very simple to also have a WordPress operator sharing a lot of the same code as the Drupal operator. And otherwise, the operational model should be essentially the same. When will be there another comedy night? What other question have I not? UX, is there a mandatory theme or style guide? Kath, maybe you know better if it is mandatory.
I think Kate will be able to provide a bit more information on the mandatory style of things. So there is a style guide, and we do have a CERN theme. So the advice is anytime there's a public-facing website, we use the CERN theme. If it's mandatory, that I don't know about, but I'd say very, very strongly advised to do so, because we want to present a consistent look and feel to all of our websites that face the public. Style guide, yes, so that's things like logo color, position, colors used on the website, that kind of thing. So that there's a strong branding presence, but we still do have quite a lot of flexibility around that.
Someone is asking, Alberto is asking, do you always deploy your CERN distribution, or do you have other variations of deployable products? Right now, we deploy only the CERN distribution, but we allow users a workflow to customize it with additional composer modules. How this looks like is that the CERN distribution is fundamentally a composer project with a set of pre-installed modules, composer packages, and we provide that as a base for a source-to-image recipe that allows users to, site builders, to provide with a repository of their own, a Git repository of their own containing simply a composer.json file with a few additional modules that they want to include. And the source-to-image process will create a new image then, which will have our original composer.json, and using the composer merge plugin from Wikimedia, it is a composer plugin that you can find upstream, we merge the requirements of the user-provided composer.json. So we create a new composer.json with our own things that cannot be overridden with the new module that the user is adding at the bottom. And then we run a composer update to composer install. I'll say about the difference here, to create the final site builder image that is case specific in this case. So in that sense, we allow some flexibility to veer away from the CERN Drupal distribution. But here is the important part from our perspective. We do not allow people to override the modules that are provided centrally by us, because we offer a certain level of service in this infrastructure. We say that we are responsible for X. One of our problems, as I mentioned in the slides, was that when the crisis moment came, there was a bit of a responsibility gap between what the infrastructure team is responsible about and what the individual site builders are responsible about. And this was a consequence of, you might say, some lack in communication, but also fundamentally the degree of freedom that we want to give to the service, which, as far as I know, is pretty high compared to other such services. So in order to make sure that we can provide the service that we promise, we want the base that is the CERN Drupal distribution to be unalterable by the users of our infrastructure. Hope this answers the question. Is there anything else that came in the meantime? WordPress is a low-code solution. Well, I have to say that we haven't seriously evaluated WordPress yet. All we know right now is that there are voices in the community that say, oh, we would like to have a WordPress site, and we know that it would be rather easy to also deploy it. It doesn't mean that we will do or that it is indeed the right thing to do for us. So let's take a moment actually to look at your answers at our poll questions, because I'm super curious to see if there is interest for extending our development to make sure that the infrastructure works, the infrastructure components work outside of CERN as well. So the first question that Rayula, my colleague, had asked is, how do you manage communication among the Drupal communities in your organization? Are you using, for example, a forum like what we proposed, internal messaging tools, meetings, or not applicable? Let's see what the results are. Apparently, 25% of you, don't worry about Kath, she has a bit of an unstable internet connection. About 25% of you are actually using an internal forum, a discourse in your community. But even more of you, 40% at least, are using an internal messaging tool. So it looks like some of you are using this, but it is not too widespread yet. So maybe with our experience, we might be encouraging broader adoption, seeing how it has helped us a lot. So the second question is this infrastructure useful to your use case? And I see that 50% of you say yes, that it is useful. 20% say no, and 30% are saying maybe. So for me, this is a rather strong signal that it would be interesting for the community to make sure that our components, which are already open source, are capable of working without CERN integrations.
You have another question on Q&A.
Thank you. What is it? If you wanted the low-code solution from the beginning, why did you stick with Drupal for this relaunch? Because it wasn't a relaunch. I will also let Kath say something on this. Kath, we were just asking the question, if you wanted a low-code solution from the beginning, why did you stick with Drupal for this relaunch? First of all, let me say that it is not a relaunch where we made everything from scratch. We had already a plan that we wanted to migrate from Drupal 7 to Drupal 8 because there was a lot of strategic investment in Drupal already with the theme. But maybe Kat has something more to say.
No, I think you pretty much said it there. I mean, we've had a very long history with Drupal, going back, I don't know, to Drupal 6, and we had some involvement in the early days with Acquia was back then. I don't think, I'm trying to think how to answer this one. It's, I mean, as Konstantin said, you know, we've invested a lot in Drupal over the years. It's worked for us. We didn't want to support too many tools because, you know, we're also not a hoster or a provider. So Drupal was a natural solution to keep going with it. You know, as Konstantinos has also said, there's been some interest in WordPress. But fundamentally, so far, it's worked for us. We can't keep investing in infinite number of low-code solutions. So that's I don't know if it's a very satisfactory answer, but that is it. It's we've been in it for a long time, and no reason to do any radical change from both resources and from experience as well.
I mean, it has been good enough. For the most part, complaints are specific for specific things. We haven't had too many complaints about, you know, the entire framework that we are using. So there was never too much of a big push to move to another thing. There were always been complaints about this and that, but they were just not such a big forces to say, oh, it's a great idea to just pause everything that we've done and move on to a different system.
Yeah, but there's always complaints about everything, by the way. You have to calibrate what's a valid and what's just, you know, other.
Yeah. Yeah, no, that's our daily life. Complaints about everything. Sergio says, an interesting solution, equally interesting governance model. I see a lot of people.
Actually, I think the governance issue, and this is one of the benefits of CERN, because we're a very, very collaborative environment. And I think that's one of the great things about CERN, actually, is we can kind of make things like this happen because we can see it's working for people. So why would you not do that? So yeah, sidesteps a lot of issues, exactly. Yeah.
For me, at least, this is really a core principle of CERN. I could not imagine CERN as a walled garden where people don't really collaborate and keep knowledge to themselves or anything like that. CERN is built on that.
Okay, so are we at the end of our session now, or?
Yeah. Okay. I think we've answered all the questions also in the Q&A. Forgive me if I have skipped something. I went through them all again, and I think I have indeed answered all of them. There were a few that I answered a bit fast. So if you like to keep up with the chat, I think we have to close the session now, but we probably have a messaging solution in Hopin, and you can just drop your message. I think there is something like that. Yeah, I see that there are direct messages. So feel free, everyone, to drop me or Kath or anyone from our team, Ragula or Francisco, a message to continue any more discussion in depth. We'll be happy to do that. Someone is asking Drupal log. Do you write them to SQL or use Loki? First of all, what is Loki? I have no idea. Oops. So we take Drupal logs directly from the containers, and we use FluentD to send them off on their way to our central monitoring infrastructure. That is what I can tell you. This is an infrastructure component that we are reusing from the platform as a service solution as well. I haven't looked too much into it. What I know is that at the first level, we see the Drupal logs emitted from every container, and at the other end of the pipeline, we see them in our centralized monitoring system. In general, we rely on the monitoring service at CERN, a centralized service which offers Grafana for time series metrics, essentially, and Elasticsearch for logs. So we have this dichotomy in our observability tools, if you like. We send time series metrics from Prometheus, which natively monitors everything that happens in the cluster. We see things in Prometheus monitoring natively, but we could also export them to the CERN monitoring service. We will at some point. And on the other hand, we see logs from the Elasticsearch Monit Timber dashboard so far. But this is interesting. I like the mention, and we can look into this.
Okay, I think it's
Okay, then.
time for virtual coffee. So,
Thank you very much. Bye-bye.